this is Group 2. Our group project is the load balancer system. Since this is the second version of our system, we'll focus on the new features of the system. But before we start, we'll perform the program first. We will start 2 servers and multiple clients in this demonstration. Before we start sending requests to the server side, I would like to mention that different colors of the messages, what they indicate. So if the color of the message is blue, it means the thread currently is processing or computing something. For example, the server thread messages in blue indicates that the server thread currently processing the request. So if the color of the messages is green, it means that a thread has successfully performed the task. For example, a request has been successfully allocated to a server for load balancer thread, and a request has been successfully processed for the server thread. So if the color of the message is yellow, it indicates that something is unavailable. So for example, for the load balancer thread, if it prints yellow messages, it indicates that currently the server that it plans to assign to is unavailable or overloading. So for example, if there are lots of yellow messages printing by the load balancer thread, it indicates that there's lots of requests and currently the server is overloading and cannot accept additional requests over the capacity. Another reminder is that every time I press 2, the system will create a new client thread to start sending requests to the server. So the number of times that I press 2 is the number of client threads that the system started. And if I press 2, keep continuously pressing 2, there is a multiple client thread start sending requests simultaneously, which means at the same time. We can see that different color messages scroll continuously from the bottom, indicating that the load balancer thread in the system is distributing requests to different servers, and at the same time, 2 server threads are processing the request distributed by the load balancer. Since each server has an upper limit on the request capacity, when the server reaches the limit, the load balancer must wait until any server is free again. When one server is full and the other is not, the load balancer distributes new requests to the available server. At the same time, due to the delay feature, it will take about 4 seconds for the server to process a request. So we can see that the server only completes its request after a few seconds. So currently, because I have started too much client requests and the load balancer kept printing the yellow messages, which indicates that a server is not available or overloading, and remind me to start a new server. And at the end of the process, when the most of the requests has been allocated and processed, the most of the color messages is blue and green. So there's only one yellow messages from load balancer. And right now we can see that the server thread has finished their tasks. So right now, currently, the server 2 and the server 1, both of them has finished the tasks that are assigned to them. And we're going, so since the first feature I have mentioned that. So the first feature I have mentioned. And I'm moving to the second feature is the reach state of the server. And as you can see, there is a multiple states of the server, including the listening state and the processing state and the sleeping state, and which presenting the interval of two listening moment. So currently server 2 is listening, but it will fall into sleep if there is no request and wake up on the next time, and it will check. If there's still no request, it will fall into sleep in the next interval between the two moments. So let's move to the next features, the server capacity. We can see that the server capacity is the twice weight value of the server. That means the 6 is twice value of the 3, and the 3 is the weight value of the server. So we can see that the first server can accept 6 requests one time, and another can accept 8 requests at one time. And what does the capacity mean? It means the list of requests that inside the server can only be the maximum size of 6 in these cases. That is, whenever the load balancer assigns a request to the server the request list will add the request, and the server will start processing. And after it finished, the request will be moved out from the list, and the list size, the maximum of the size is 6 in these cases. So let's move to the latency. As we can see, because of the latency, that it takes seconds for the server to process one request, and because of this, it takes minutes to finish all the requests and return to the listening state for both of the server. And finally, you can check the server file, and you can see that the sequence of the client request is in a random format. Its sequence is random. So in the first version of our system, the sequence is fixed, while in the second version of our system, which is the latest one, the sequence of the request log is random and have no correlated between each other. This is because the different server capacity and the server latency cause the uncertainty of the request distribution for the load balancer. So that's all for our project. Thanks for watching. Bye bye.